The camera doesn't move, and from its current position cannot see very much. We need to tie the camera to the player game object. First, let's set the position of the camera. Let's lift it up by 10 units and tilt it down by about 45 degrees. Next, let's make the camera a child of the player game object. This is a typical third-person setup. With the camera as a child of the player, when we move the player's position, the camera moves with it. When the player rotates, the camera rotates as well. Let's look at this from a position where we can see both the player and the camera game object. Move the player, rotate the player, the child camera moves with it. Now let's reset the player and test. We enter play mode, hold down the up arrow to move. Whoa, what's happening here? Okay, well, as the camera is a child of the player's sphere, even though the camera is not moving at all relative to the player's game object, the player game object is rotating like crazy, so the camera's point of view rotates with it. Let's exit play mode. Unlike a normal third-person game, our player game object is rotating on all three axes, not just one. In a typical third-person setup, the camera, as a child of the player game object, will always be in a position relative to its immediate parent. And this position will be the parent's position in the game, modified or offset by any values in the child's transform. We can't have the camera as a child of the player, so let's detach it. Our offset value will be the difference between the player game object and the camera. Now we need to associate the camera with the player game object, not as a child, but with a script. Using the Add Component button, choose New Script. We are writing in C# and name the script Camera Controller. And then click on Create and Add, or simply hit the Return or Enter key to confirm our selection. We should note, this way of creating a script will create that script asset on the root or top level of our project view. File Camera Controller in the Scripts folder and open it for editing. We need two variables here: a public GameObject reference to the player and a private vector3 to hold our offset value. Offset is private because we can set that value here in the script. For our offset value, we will take the current transform position of the camera and subtract the transform position of the player to find the difference between the two. So in start, we can make offset equal to our transform position minus the player's transform position. And then every frame, we set our transform position to our player's transform position plus the offset. This means, as we move our player with the controls on the keyboard, that each frame, before displaying what the camera can see, the camera is moved into a new position aligned with the player object, just as if it were a child of that object if it were not rolling around the game board. However, Update is not the best place for this code. It is true that Update runs every frame, and in Update, each frame we can track the position of the player's game object and set the position of the camera. However, for follow cameras, procedural animation, and gathering last known states, it's best to use Late Update. Late Update runs every frame, just like Update, but it is guaranteed to run after all items have been processed in Update. So, when we set the position of the camera, we know absolutely that the player has moved for that frame. So let's test this. Let's save our script and return to Unity. First, we need to create a reference to the player game object by dragging the player game object into the player slot in the camera controller's component. Enter play mode. And now we get the behavior we want. The camera follows the rolling ball without rotating, even as the ball goes over the edge. In the next assignment, we'll set up the basic play area and create and place our special pickup objects.